Hey everyone, my name is Anvita Bansal and we are back with another lecture based on stacks. So the problem that we are going to discuss today is get minimum element from stack. So this is from our SDE sheet. So this is the question that we will be discussing today. Meanwhile, I'm just quickly checking if I'm live. Yes, I think we are good to go. Okay, so you are given, the question is that you are given n elements and your task is to implement a stack in which you can get a minimum element in O1 of time. So if I cut this question short for you all, so it's all about implementing one extra function, or you know that in layman terms we know that we have a stack, right? And the operations that we directly use on stack, the methods that we use of stack directly are push, pop, right? These are the operations that we use on stack. I hope you all are aware of it by now. So we just have to perform one more method or one more function, which is get min. So this function will return us the minimum element so far present in your stack, right? So what happens is when you say pop, what is removed? You implement, we are not explicitly implementing this function, we are directly using this method of stack. If we are like when we are coding, we are directly using st.pop, st.push. So but somewhere they must have been already implemented by some class, right? So now we are going to do the similar kind of thing, just that we are implementing this function whose task will be to return the minimum element we have found in stack so far, right? So this means what? Now why, you must be wondering then why this question has other functions to implement like pop and push. These should remain same. I will simply do push and pop. Why I have to explicitly go ahead and write these functions? So the reason for this is when we would want to get this get min function, there will be some things that will have to change while we are pushing the elements into the stack or while we are popping them, removing from the top of your stack. So how these changes will appear, let's dive into the understanding of this thing. Let me just explain to you what this question is going to look like, or how the operations are going to look like. So let's say that you are given some numbers, some elements, integers that you have to push into your stack. I'm just writing those elements. So let's say we have 18, then I'm asking you to push 18. Wait. So let's say first I ask you to push 18, then push 19, push 29, then I ask you get minimum. Actually, let this be get min, let it be 17 or 15. Okay, then I ask you get min, then I ask you to push. We are just creating an example. I'm creating it in such a way so that you can very easily understand how operations are going to look like. Then I say pop, then I again say get min. Okay, then pop and get min. Let's see till where are we going to go to implement it, but have a look. Okay, so these are some elements that I have given you that you need to implement. So when I say push 18, what should be happening into my stack? So into my stack, what must be happening, that I have a stack. Let's say I have created one stack in which when I say push 18, 18 will go and get into this stack, right? When I say push 19, you go ahead and push 19. When I say push 15, you go ahead and push 15 into your stack. Now I am asking get min. So tell me what is the minimum element so far that you found in your stack. So far you can see that 15 is the minimum element. But while you were pushing these elements into your stack, were you keeping any kind of tracks how to get this minimum element? No, we were not doing it. We were simply pushing the elements into the stack, and we don't know which is the minimum. So are you going to remove each of these elements one by one and then compare which is the minimum? No, that is also not a good idea. So what can we do? One thing might be coming to your mind, that while we are pushing, let's keep a track of minimum. For example, when I pushed 18, my minimum was 18. Then I pushed 19, I will compare what is minimum. If I find it less than the minimum, I will update my minimum. Should I do it like this? Let's see if we can. Now, when I push 19, minimum will be still 18. Now I pushed 15, minimum will be updated to 15. Okay, fine. Now if I go ahead in this way, see where the problem will come. What I'm doing, I'm keeping a track of minimum elements in this minimum variable. Okay, but let's see what is the problem with this approach. Now I'm asking you, I have not removed them, 18, 19, 15. Let me just push them, 18, 18, 19 and 15. Okay, so what will happen is that when you have 15 and I ask you get min element, so at this point in time you will get minimum 15. Okay, you got 15, but you have still not removed 15. Let's say after this get min, I ask you to pop. Okay, so you will remove this element from the top of your stack. Okay, now what you have in your stack is 18, 19. Now let's say I say you again get min. So, and during this time when I ask you get min, what should ideally be the minimum element in your stack? It is actually 18, but minimum is still stored with 15. Why? Because earlier it was 15, I did not update it, and somehow my pop function asked me to, I called my pop function which removed the topmost element, which was this 15 only. But I did not update my 15. Now how do I do this thing? That is the issue. You must be thinking, when I remove any element, I check if I'm removing the minimum element or not. Even if I check, how will you make sure that you are getting the minimum, next minimum element should be 18, and in minimum you are storing 18 only for this scenario? How will you make this thing sure? So to ensure this, we have come up with some mathematical manipulation. So what is this mathematical manipulation is? Let's see what can we do. So this is one possible solution that we can do for this problem. It's widely accepted down the line, lot of times, not a lot of times, most of the times we do this question by this solution only, but this is something that has been mathematically thought. Okay, so there is something that we can do. So that's, but I will suggest you to think if you can do something else also, which is definitely possible. So let's see the approach that we are going to do. Okay, so what are we going to do is, whenever we are pushing an element, okay, let's say as I discussed, we will be keeping a track of a minimum element, right? We are keeping a track of minimum element in min, but in a different way. What is that different way? So first let's push the elements. Right now I am pushing 18. My minimum was initially nothing. When I pushed the first element, my stack was empty, so minimum will become 18 only, right? Fine. Next element that I am pushing into my stack is 19. Now I compare 19 with minimum. 19 is greater than min element, so obviously my min will not be updated, right? So I will push 19 directly. Next element is 15. Now I see that 15 is less than the element that is present in min, right? This 15 is less than minimum. Then I must do something. What should I do now? That I'm going to do some mathematical operation, which is actually to store an element which is even less than this 15. How? See, 2 times of this min. Actually what I'm going to store is 2 times 15 minus this 18. What is this representing? That is 2 times x. Let's say the element that you are pushing is 15, that is x. And what is your current min element? Minus cur min, or you let me write it min, minus min. So this is exactly 2 times 15 minus 18. What will this give you? So that will be 30 minus 18, that is equal to 12. So I am going to push 2x minus min. Why am I, now you must be thinking, why am I doing so? You just have to, just see the steps, just keep faith for this particular test case, then you will understand why we are doing this and how this is helping us. So instead of pushing the exact number that I'm pushing, when I find that the number that I'm trying to push into my stack is coming out to be less than the current minimum element, so instead of pushing the element exactly as it is. I am doing some calculation which is pushing 2 times of that element that I am going to push minus the minimum element that is present in my min variable. So that will make me push 12. See, even if I push 12, one thing is for sure, that 12 is going to be less than this minimum, right? And then I will update my min from 18 to this current element that I used as x. So my min will be updated to 15 only. Okay, why I did so? Just look for one more step and you will understand. Okay, next step is, next element that I'm trying to push is, let's say it's 20. Okay, I compare 20 with the minimum element 15. It is greater than 20 is greater than min, so I will push 20 into my stack. Okay, let's push 20. Next element, let's say I am pushing, don't have a look here, let's say I'm pushing 10. Okay, so you will observe that 10 is less than minimum element that is present here. When 10 is less than this, then what I am going to push, I will not push 10 as it is, I am going to push this. So I will push 2 times 10 minus what is minimum present right now, minus 15. So that will come out as 5, right? 20 minus 15. So I will push 5 here. Okay, let's see. Now, and your minimum will be updated to the element that I was going to push. So which element was I going to push? I was going to push 10. Okay, so this will become 10. So first it was 18, then it became 15, now it became 10. Now wait, these are the things I have pushed. Now one by one, let me just erase this test case because I don't think so it is of any use. We did differently only. My idea was, I am writing the elements that I have pushed here. So we pushed 18, then we pushed 19, then we pushed 15, right? Then we pushed 20, and then we wanted to push 20. So these are the elements that I wanted to push. And right now my stack has elements like this because we made some manipulations on the elements. You have to stay with me and understand what we are doing here. Otherwise you'll miss out on what we are actually trying to do if you've not done this question before. Now wait. Now these were the push operations. Now I am asking you to pop. Now go ahead with pop. So when you are popping, that is removing the topmost element from your stack, you have to check, because we have pushed, whenever we found an element which was less than our minimum value, we made some manipulations on that element and then pushed it into your stack. So whenever you are removing an element from the top of your stack, you are asking, is my st.peak element, is it less than the min element? So if you find it less than minimum element, that means that there has been some calculations on the element that I pushed, right? So you have to, when I ask you to pop, you have to return me the exact element that your question that you actually wanted to push in the stack, but you did something else. So actually when I say pop, you have to return me 20. Now from this 15, how will I get 20? That is the question here. So let's see what we wanted to do. Sorry, this pop should return me 10, right? Because the last element that I pushed into the stack was 10, but instead of it, I made it 5. Now when I check this element, 5, what is your current minimum? It is 10. So 5 is less than 10. That means it is not the exact value that I wanted to push. I made some calculations. Now to retrieve the original value, what I'm going to do, that is 2 times minimum, 2 times min minus, what did I do? See how I pushed this element. I pushed 2x, right? The original element. So 2x minus min during that time was this 5. Okay. And then, sorry, one thing is sure. You will see that whenever you are asking for a pop, you will check what? Let me remove this. See, for pop operations, you are going to do this thing. Let me write it here. For pop, you will check your st.peak. If st.peak is less than your minimum value, so you return what is present in min, right? See, the last element that we wanted to push into stack was 10, and you will see that the element, if it is present at the top of your stack, is less than min. That means the original element that you wanted to push was 10, and you made some calculations which made the element present right now at the stack lesser than the minimum value, right? This is whenever I find an element lesser than the value that is present in min, this means that this is a manipulated value, and the exact value is present with min, because that's how we made the calculation. Okay, you return min. Now when you remove this element, you have to also update your min. See, because now actually 10 is no more present in your stack, right? So min, you have your min, this min should be storing the minimum of these elements, means these elements, to be more accurate. So what is the minimum of these elements? It's 15. So ideally this should be brought back to 15. Now how will I bring back to 15? That you will see here right now. See, how did we push element here? How did we push element here? That you can easily find like this. This was the previous element that you found, right? So what did you do when you did like something like this? 2 times, how was this 15 pushed? See, 2 times the current element. You actually want to make this minimum 15. So what are we going to do is that whenever if we have removed this element, now what you will store, this thing is little bit tricky for you to, means this can be a little bit tricky because this has to be understood. So what is it now? Now your value, store your value with the element that is present in min. Okay, that is, let's say 10 right now. Fine. Now what your minimum element will be actually 2 times that is present in the minimum element, that is 2 times of 10 minus st dot pop, that is 5. So 20 minus 5 is what? 15. That's how you will get your minimum updated to 15, right? Now your minimum is 15, and since you are returning the element that is present in your val, because val was minimum that time. Okay, when we will code you will understand then, and you finally return min for this. Okay, why did we do so? Now coming back to, let me explain to you while we were pushing. Now I'm coming back to why we did so, 2x minus this min. So have a look here. When I pushed 18, my minimum was 18. Okay, when I pushed 19, my minimum was still 18. When I pushed 15, the thing is, I want, instead of pushing 15, I am doing it this 2 times this x minus what is present in minimum. I want to push it, and when I push it, this thing is ensured that this will be less than the element that I am pushing. It will always be less than 15. How am I sure about it? So let's see here, x is equal to 15, let's say. X, I know it is less than minimum. It is less than my min. So 2x will also be less than 2 min. That is nothing, but I am simply doing x plus x and min plus min. Okay. So I'm just making you understand how this expression is working. If my x is less than my minimum value, which is the case here, 15 is less than 18, right? This is your minimum right now. So x plus x is going to be less than min plus min, right? So if I do, x plus x will become 2x and bring this minimum from here to here, 2x minus min. It will also be less than minimum only. So when I found an element, when I find an element which is less than my current minimum value, so instead of pushing it as it is, let's push 2x minus min, because that will still ensure that the value is less than the minimum that is right now present in your stack. So when I do so, I push 2 times 15, that is 30, minus what is your current min? 18. So instead of 15, I am pushing 12 actually, right? And my minimum will get updated to, my min will get updated to this x, because actually I have to operate on the values that I am trying to push, but I am not pushing that exact value because that is due to the manipulations I am doing in order to get my right answer. And I told you why we are doing this. So minimum will be updated with 15 in this case. Now the thing is, why we chose this value only? Why? Coming on to why we chose this value is because when I am removing the element, now if I call pop operation, So you see the top of your stack is 12 right now. When the top is, you compare and you find that top is less than the minimum value. That means this value originally, what was it trying to push? Basically your stack is right now 19, 18, 19 and 12, right? When I'm calling for pop operation, and when I call for pop operation, you check that the topmost element is less than my minimum value. That means that I should not directly go and say return stack.pop, because this is value that is being manipulated. This is not the exact value. Now in order to get the exact value, I will have to do something. That something will be, you will see that the element that I wanted to store will be stored with your min variable. The reason is the topmost element being less than min indicates that this value is minimum so far in your stack, right? That is why it is less than min, because of this expression. So if it is the least element, means the smallest element of your stack, so my min variable must be storing the exact value that must be actually at the top of the stack. So when you call a pop operation, you are actually returning the element present with your min. You are returning the element present with your min. But before returning, what we are doing is, okay, I remove this element from the top of my stack. I removed it, but before removing it, I will also have to update min, right? Because once I get rid of this topmost element, the minimum should be stored with with 18. So how will I get this 18? So you have to see this thing here, that when I was pushing 12, when I pushed 12, how did I get 12? I got 12 by doing 2 times of this value, which I was supposed to push, but I did not. So 2 times of 15 minus what should have been present in this min gave me 12. So basically I did 2 times of 15 minus what min was that time present, gave me what the answer that is present at the top of my stack. So minimum will be what? That will be 30 minus 12, that is equal to 18. So you update min with 18 now, and then you return after this. Once you are done with this update, then you return the minimum that was previously present, that was 15. So before doing this thing, I will take one more variable in which I will store the value of min, and then I will update my actual min and return the value that I took, let's say temp. That temp should be returned while you are removing the element from the top of your stack. This question is a very good question. Let me know if you have any doubts in the explanation so far. Now when I start coding, you will be easily able to relate what I was trying to explain. Okay, so basically it comes down as, when you are writing your push operation, it's coming down as, you just don't go ahead and simply push. If your stack is empty, let's say empty, if your stack is empty, what will you do? You will simply push the element that you want to push, let's say x, and update your min ele with x. In the else case, what you will do? See, there will be 3 cases. If stack is empty, there is nothing in the stack, you push the element and make min element pointing to this value. Okay. Second case is if the element that you are pushing, it is less than the minimum element, right? This will be the second case. So in this case, what will be pushed? You will push st.push, as I told you, 2 times that value minus minimum element, right? We discussed this thing. And in the else case, if the value stack is also not empty and the value that you are pushing is also greater than the value present or the minimum element, right? There is no issue, then you will just simply push. In the else case, you simply push st.push this element that you are actually want to push, right? st.push x, right? So this will be your push operation. Fine. Coming on to pop operation. Get min Get min will simply return you min element that you will be storing somewhere in your class. We will define min element equal to anything, right? We will define min element variable which will be storing min element throughout all the operations, and get min will simply return this min element. The issue will come when we will be calling pop operation. So I told you how we will handle pop operation also. It will not be just simply removing from the top of your stack. You will have to check if stack dot peak value, if this value is less than your minimum element. I told you what and why to do, right? So if that thing is still not clear, I'll really suggest you to, once we are done with the lecture, you can go through the lecture once again and try to understand this thing. I've taken this thing repeatedly so that you can understand, because a lot of times this thing happens that we are not able to understand why we are doing this. So this why should be clear. For that you can go to the part which I have just discussed before writing this code. Okay, so in pop operation, whenever we find that the top of my stack, let's say 12 was there, 18, 19, 12 is less than my minimum element, and min must be stored with 15 right now. So that clearly indicates that first of all, the value that should have been pushed into my stack will be stored with min, right? So I will store int, let's say int val will be stored with the min element value, right? And then I will do manipulation, that is I will update my min to 18 because I want to remove the topmost element. So minimum should be updated with 18 now. So my min element will become what? 2 times that is present in your minimum right now, 2 times this min element minus st.pop. You are simultaneously removing the topmost element from your array, right? st.pop, that's what you are doing. And once you are done with this, you have updated, you return the value that you have stored here, because for this the peak value was 12, which means the value which should be returned is 15, which is stored with val. So you return val. So this is the case when the value that you are trying to remove from the top of the stack is less than the minimum value. If let's say that is not the case, for example, now the minimum, you have 18 and 19 and minimum is stored with 18. So you compare the top of your stack, it is greater than this, so you just simply return st.pop. In the else case, you don't even need to write else case, simply write st.pop. That is all. That's all that we are going to do. I'm just going to through your chats if you have any doubts. I don't see doubts as of now. So let's go ahead, and I have written the pseudo code as well. We will go ahead and code now, right? So I hope you have no doubts. Let's move to the code now. Okay. So what are we going to do? Your stack S is already defined for you. I am also going to, minimum element is defined for you. This is okay. So let's go and write the code. What is the use of this? Fine. Just press it. We don't need to define the constructor class. Let's go ahead and write them. So for minimum element, what are we doing? So for minimum element, we are checking if stack is empty, if s dot is empty, what you are doing, you return -1, otherwise you return min element. Min element, that is here, stack has been defined for you, so you return min element. That is your get min operation. Now talking about your push operation. So for push operation, what we are going to do, I told you we have some calculations to do. If the element that we are pushing is, we have divided push into 3 parts, if, else if and else. So if case is, if s dot is empty, empty, right? If that is the case, you simply push s dot push that current value x, right? And then what you do, make your min element equal to x, right? This is your if case. Now coming on to else if. Else if is the element that you are trying to push is less than minimum element. Then you will not push x as it is, you will rather push s dot push 2 times x minus min element, right? That's what you're going to push. and then you will update your min element with x, because that is what you wanted to push. Since it was minimum so far, you actually push 2 times x minus min element, that will also be less than x, this minimum element only, that is x. Okay, and in the else case, simply s dot push x, that's your push operation. Talking about pop operation, again there are two cases. If first of all you check if s dot is empty, right, what will you return? Return -1. Then you have if s dot peak value, it is less than min LE. Okay, if s dot peak is less than min element, then what should you return? First of all, you know the element that you want to return will be stored with min element only. So let's take a variable val and store min element there. Okay, and then you have to update your min element. So min element will be updated with 2 times your min element minus s dot, remove the topmost element as well, and then you return val. Fine. Okay, and in the otherwise case, if let's say the element at the top of your stack is not less than your minimum element, then simply remove the element. No calculations are required to be done. So not st, it will be s. Okay, otherwise you do s dot pop. So let's see if we have any doubts here, or if there is any error that we are getting, we'll check it. Where is it? What is the issue here? 2x 23 we are doing pop pushing. If it is empty, we push s dot push x minimum terminal pointer exception. Let's see what is the issue. This is your if case. Else if x is less than, that is fine. Otherwise we are simply doing this push. If s dot is empty, that is fine. Now in the pop case, if s is empty, you're returning -1, that is also okay. If peak is less than, then will is fine. Otherwise you return s dot pop. I think that is also okay. Then what is the error? If s is empty, it should not be giving error actually. Let us see. As if stack is empty, you're returning -1, otherwise you return min element. For pop, if stack is empty, you return -1, that is okay. If stack dot peak is less than minimum element, s dot pop 2 times minimum element, return value. Because you're doing s dot pop push. If s dot is empty, stack dot push x and minimum element will be updated. It should ideally work. Let me check. Let us check our previous submission. If you guys see the issue, let me know. Let me just take our previous submission. Maybe okay, we did not define it. Shit. And I did not submit that code also. Okay, fine. I think that will work. So there was no issue with it. I did not actually initialize my stack. That was the issue. So your stack, what happened was, the issue was, your stack was like this previously. Okay, so if you try to compile it, it will give you error. I think that was the error we were getting. Let us see, because we have to initialize it, right? It has just been declared, that is why. New stack, new stack. Now you can see we'll submit it. Fine. So I hope you got the question, and I don't see any doubts here. So we will wrap it up. This was a good question. I'll suggest you to go and do it yourself if you understand it. If not, try to understand the logic from the video and then try to attempt the code on your own. Okay, so that was all for today, everyone. See you all in the next lecture then. Bye bye, take care. Okay.